All right, today we are going to look at dilation to begin this geometry review by request. So dilation is when you make something bigger or smaller, okay? If you're dilating it bigger than 1, it's bigger. Smaller than 1, it's going to get smaller decimals. And this one, we're going to dilate it from the origin. There's a really easy way of dilating something from the origin, but I'm going to show you the normal way because it works if you don't have the origin as a point that you're dilating from. So we're going to find the corners, and we're also going to make sure we know where the origin is. And what you want is you want corners that are on a horizontal or a vertical line from your location of dilation. So in this case, the origin. So we've got two corners that are either vertical or horizontal. And we're going to count the distance because we want to dilate by 3, and that's actually really simple. If there's a distance of 2 and you dilate it by 3, you just multiply that distance by 3. So now we need a distance of 6. So we started with a distance of 2, and we want it bigger by a distance of 6. We're going to do the same thing here. This is a distance of 3 boxes. We're going to multiply it by 3. And now we're going to increase that to a distance of 9. Okay, so instead of a distance of 3, we want a distance of 9. So that point is now out there. Any other sides that are vertical or horizontal, you can actually do the same thing too. So we have a side of 2 that's going up. We want it to go up to 6. And that horizontal side of 3, we want it to go out 9. And then once you have all the corners, you just connect the dots. And as long as you stick with horizontal and vertical sides, you don't have to worry about the diagonals and getting Pythagorean involved. Okay, so dilating means find your horizontal and verticals. Okay, how far are they from the point you're dilating out of? All right, and then you just multiply your dilation number by that, and then you go out that distance, and then you connect up all the points once you're done. Next up, we are going to explore the world of angles and transversals. So something to know about the vocab in this, because angles are primarily vocab here. Corresponding, alternate interior, alternate exterior, and same side interior are one class of angles that require 3 lines in order to make them. Okay, you need angles that are going to be on 2 lines, 2 separate lines, and then you need a joining line. So that's the corresponding alt-int, alt-x, and all the same side stuff. Okay, you need 2 angles to be on 2 different lines and then connected by transversal. That's the line that they both share, and then there's lines that they don't share. Vertical and adjacent are different. Vertical and adjacent, you only need 2 different lines, two lines period. Okay, in order to do this. And the angles will share both of those lines. So vertical are opposite sides of the x. Okay, and then adjacent, they're next door to each other, and there's a line in between them. Okay, that's vertical and adjacent. So vertical and adjacent, you don't need 3 different lines. You just need 2 of them. Okay, you don't need 2 separate and a joining line. You just need 2 crossing lines. Okay, we're going to come down here on 15 and we're going to highlight the parallel lines. Okay, those are the lines that you need if you're going to do anything that is not corresponding, that is not vertical and not adjacent. Okay, if you are in between both angles, if both angles are in between those parallels, those highlighted parallels, those are the interior angles. Okay. If both angles are outside the highlighted parallels, then they would be considered exterior angles. Okay, so interior is in between the parallels, exterior is outside the parallels. I'm going to highlight in pink this transversal. That's the line that's cutting across them. Okay, if your angles on the transversal, if they're on the same side, they're both under it, they're both left of it, they're both right of it, then they're same side. And if they're jumping the transversal, that's alternating. Okay? Doesn't matter if they're interior, exterior, if they jump the transversal, they're alternating. If they're on the same side of the transversal, then that's same side in interior or exterior. Okay? Inside, exterior. Okay? If they are on different sides of the transversal, that's the alternating. Okay? Which then leaves us with kind of one weird one, is what happens if one's inside and one's outside. And I'm going to show you on this other pink transversal. I'm going to highlight this kind of upper right angles. One of them is labeled X, one of them is not labeled at all. So these upper right angles, see how they're upper right in both of their little areas? So like that little area of two lines, they're both upper right. That's corresponding. Okay, corresponding is kind of the weird one. One of them's inside, one of them's outside, and the reason is because they're both upper right. They are, though, going to be on the same side of the transversal, but they're not both inside and they're not both outside. Next up, areas. We're going to hit lots of different area formulas. You have plenty of things to choose from. So we'll start with the basics. Parallelograms. That's all the rectangles, the squares, anything with two sets of parallel sides. Parallelograms are the simple ones. Area is base times height. Make sure your height is doing a 90-degree angle from a base, or from an extension of a base. Okay, so that 90-degree angle is important. It's not side times side. It's a height and a base, which would be a side length. Okay, related to the parallelograms, if you divide a parallelogram in half, we'll do that right here, you get a triangle. It's a triangle is half the area. There's a base, we got a height. So if you take that area for parallelograms and throw a half in front of it, that's the triangle. And once again, the height does have to have a 90-degree angle from the base or an extension of the base. So triangles are half the base times the height. Everything is kind of dependent on the base and height. That 90-degree angle, critically important. All right, trapezoids. Okay, two parallel sides, or a single set of parallel sides, and the other set of sides not parallel. Okay, now trapezoids are related enough to parallelograms that they're going to go with the base times the height, but the problem is they've got two bases. So how do you know which base to use? I mean, is it the big one, the little one? Or what if we did, somewhere in the middle? So we got two bases. What if we averaged them? So if we took the bases, that's the set of parallel sides, add them together and divide by 2, you're finding an average. You're basically finding an average base, one not too big and not too little. And then you times it by the height. That needs a 90-degree angle again. That's the trapezoid area. Okay, last up, regular polygons. There's a couple of shortcuts in here, but we're going to go for just kind of the normal formula because it works on all of them. Okay, so the area of a regular polygon is a polygon where all the angles and all the sides are the same. Here are some regular polygons. Now, inside these regular polygons are triangles. And then there's this height to the triangle right there. That's called the apothem. So if you take the height of the triangle times it by the side, you can figure out the area of that little triangle. And then what we're doing is we're connecting the center to the corners. These are radii for polygons. So if it's center to the corner, but there's these triangles, and you can find the area of the triangle and then times it by how many triangles there are, that would be the area of the polygon. Now the number of triangles matches the number of sides. So there's just side, the number of sides, and we've got that little thing called an apothem It has the 90-degree angle on it. That's the height of that little triangle. I really like the regular polygon formula because it's easy to remember. It's 1/2 and then ANS, which is half of the word answer. So it's like I want half of that word, answer. Okay, A is the apothem. That's the height of the triangle, the little bitty triangle. Note that right angle, okay? So it has to hit the side at a right angle. It's called the apothem. Okay, so the apothem, you can tell which one is the apothem because it hits the side from the center, coming from the center at a right angle. N is the number of sides you have. And what that's going to do is it's going to count up all the different triangles you have. And S is how big the side actually is. So in this one, it's over at the 7.5, but it's got a side length of 7.5. That's the S, or the base of the little triangle. Got an apothem. And then you've got how many triangles there are. That's N, the number of sides or the number of triangles. So it's half the word answer, ANS. Number 26. Scary number 26. Here we go. Okay. Let's look at the instructions. We're going to assume all polygons are regular polygons. That gives us an automatic formula we can use for this thing. Okay, so that formula is 1/2 ANS. All regular polygons can use that formula. And we have A. That's the apothem. It's got a right angle. So we already have the 1/2, and we have 4 radical 3. That's the apothem. N, number of sides. We actually know that too. It's a hexagon. So we know what the N is. The N is a 6. Which leaves only one thing we actually have to figure out, and that's how big the side is. Now that's a little bit of a problem because they didn't tell us how big the side was. The only thing we've got is the apothem. But we also have the fact that this is a hexagon. Hexagons, they're the beehive shape. Okay, they're a very special shape. Their triangles that you can make out of the radii and the side are all equilateral. This is for hexagons only. No other shape does this. Okay, hexagons, regular hexagons, make equilateral, equiangular triangles. 24 happens to be one of those. So 24, the way we're going to do this is similar to the way you're going to do just 24. Okay. Equilateral, equiangular triangles. That means that all of the angles are 60 degrees, but that top angle is being chopped in half by the apothem, which is turning into a height for just this little thing we're playing with right here. That's 30 degrees, which means we have a 30, 60, 90 triangle. And if you can remember back to geometry, these are kind of important triangles. So we're going to look at just the 30, 60, 90 triangle. So we're kind of breaking it down into smaller and smaller parts. So we have a 30, 60, 90 degree triangle, and we know what the apothem, or the height of the triangle, is. That's 4 radical 3. Okay, in 30, 60, 90 triangles, the middle side is important, but the short side is the one you really want to go after. I'm going to call this guy X. Okay, he's across from the smallest angle. That's just how it works. The hypotenuse is double his size. And then the weirdo, the middle one, is X radical 3. Well, if we've got X radical 3, and we know the middle guy is 4 radical 3, then X is probably 4. But you can also do it algebraically. Okay, so we know that that middle side is X radical 3. We also know we've been given 4 radical 3. Well, let's divide out the radical 3 and find out what X is. Okay, so the radical 3's cancel over there, and we have X equals 4. Okay, and the short side is X, so we know the short side is 4. We know the hypotenuse is double that, so the hypotenuse is 8. All right. So I'm going to fill that in on the slightly larger triangle, and going across the base, the other side's probably 4, which means the whole base down there is 8. because that makes sense. It's equilateral. It should be the same. So 8, 8, 8 on all the sides. That just gave us the base, or the side length, which is what we're looking for in the area formula. So we know that guy down there is an 8, and now we have everything we need to multiply it out and get an answer. So we're doing 1/2 times 4 times 6 times 8. We're going to leave the radical 3 alone. And that's going to give us 96, and the radical 3 just kind of sits there, kind of like you do it with pi when you're leaving it in terms of pi. We're leaving this in terms of the radical or simplest radical form. But if you want to go ahead and multiply it out, you end up with 166.28 or 0.3, depends on where you round. And the instructions don't give us rounding info. So there you have it. That is how you do that polygon. Moving into the last part of our geometry review, we're going to talk trigonometry. We're going to basically just cover the trigonometric ratios. And then if you really need help, stay tuned for the last part, and we're going to do number 40, which will use them to find side lengths. Okay, so the trig ratios. We've got sine, we've got cosine, we've got tangent. Those are the three that we're going to be using. Okay, right after the trig comes the angle. So whatever angle you're using, if you know the angle, you put it in. If you don't know the angle, you put in what letter it is. For example, like over here, that's tangent x, because we don't actually know what degree that is. We're just naming it. Okay, so there's this great little thing called SOHCAHTOA, which sounds like something in another language. And you can also do, I had a geometry teacher that would do some old horse caught another horse taking oats away was the sentence that was used. So you can also do that. But anyway, for sine, the O is opposite, H is the hypotenuse. Okay? The opposite depends on what angle you've chosen. So we're going to use this little guy as an example. Let's say you're looking at angle Z. So angle Z, opposite of angle Z is side 35. That would be opposite. It's the one side that doesn't touch Z. Now the hypotenuse is fixed. It doesn't matter who you choose. The hypotenuse is always across from the 90-degree angle. But the opposite can change. So when you're looking at Z, the opposite is 35. But if we look at angle X, his opposite is 12. So the opposite is the one angle, or not the one side, that doesn't touch the angle that you're talking about. The one side that doesn't touch. All right, cosine is adjacent over hypotenuse. Adjacent is like opposite. It depends upon which angle you're talking about. Hypotenuse, though, is always fixed. So let's talk about angle Z again. So if we were doing cosine of Z, the adjacent touches. Now there's two sides that touch angle Z, or Z is formed out of those two rays. Okay, but 37 is spoken for. 37 is the hypotenuse, which means it has to be the other side. So the two sides that form angle Z, one's the hypotenuse, the other one is adjacent. Adjacent means next door, neighboring, it touches. It just can't be the hypotenuse. If you're looking at angle X down here, hypotenuse is spoken for, which means the other side that touches X is the adjacent. It's 35. Last but not least, we come to tangent. Tangent is opposite, which depends on the angle, over adjacent, which also depends on the angle. The hypotenuse does not get involved with tangent. Okay, so make sure you know which angle you're talking about, and then you set it up, and whoever's missing, solve for that missing piece of information, or if you're setting up a ratio, you just set it up like this, and you're done if you're looking for a ratio. By request, we are doing problem number 40, which is the very, very last problem on the worksheet and kind of uses all of the trig stuff. The instructions are telling us we're going to be rounding to the nearest tenth. We're going to use these rounded values to calculate next values. So we're going to have some intermediate values. That means middle answers that really aren't the answer. We are looking for the area of the triangle. Well, that's easy. We can figure that out. 1/2 times the base times the height. All right, we know what 1/2 is. We do not know what the entire base is. 44 is just the left side. The height, we don't know that either. But we do know that that's a height. It's got a right angle. And as long as you know, it divides it into two little triangles. And look at this left triangle over here. In this left triangle, we have one of the angles, 22 degrees. And we also know that bottom side, that's 44. As long as you know an angle and a side, we're just looking at the left guy, as long as you know an angle and a side, and it's a right triangle, you can find anything. All right, okay, 22, the 44 is opposite the 22. That height that we need, it touches 22, but it's not the hypotenuse, it's adjacent. So what trig function uses opposite and adjacent? I think we're going to need the tangent. All right after the word tangent, we're going to put the angle in right there. Tangent 22 equals, and it's opposite, which is 44, over adjacent. Now that's the one we don't know. That's the height. We need to figure that out. So I'm going to put in an A. A for adjacent. Okay, we need to solve for A. The problem is A is on the bottom of a fraction. You don't want A on the bottom of a fraction. And what you can do is you can multiply the A out onto both sides and then divide the tangent 22 back under. That will work. There is also a trick. I showed some of you this trick when we were doing the astronomy unit. That's called the cross swap. As long as you've got two fractions or a single fraction and a single amount, you can just trade numerator and denominator the same way you would cross multiplying. They can trade. So the A trades places with tangent 22, which is the same result you would get if you had multiplied the A out of the bottom. And then you just run it in a calculator, because that, I mean, thanks to the Greeks, that's a calculator problem. All right, A is 108.9, so we know that that's what A is, which kind of makes sense because 22 is a small angle. That means that one angle that isn't given to us, the side across from it will be bigger. All right, we have the height. Still don't know what the base is. That's still a mystery, so I'm going to leave a big opening for the base. But I now can figure out the height, and that's an intermediate value. Okay, it's a middle value that I'm going to use to get the final answer, and I've got it rounded at the 10th. What I need now is the base. I need the right side of it. Well, I now know parts of this right triangle on the right side, and 48 degrees, that's an opposite down there. And the 108.9, that looks like it's adjacent. So if I can find the opposite side, that will give me the other part of the base. I'm going to call it X, because if I call it O, it looks like a 0. So I'm going to call it X instead. 108.9 touches 48. Okay, it touches the top of the triangle, but it is not the hypotenuse for this right side. Okay, so that's the adjacent. Once again, we need a trig function with opposite and adjacent, which again is going to be tangent. So we want the tangent, and then right after the Greek word, that's where you put the angle. Here's 48 degrees equals opposite, which is an X. Put that on top. It's on top this time. I like it on top better. Over the adjacent, which we now know is 108.9. Now with X on top, this is great. If X is on top, you don't need to do any weird fraction stuff. All we need to do is get rid of that bottom amount. So we can just multiply that out because it's dividing. If you multiply it, it will cancel. Make sure you multiply it on both sides. Do not multiply it into the tangent, not inside the tangent. It doesn't hit the 48. Okay, the 48 is being taken care of by a trigonometric function. Okay, so into your calculator, 108.9 times tangent of 48, and you're going to get 120.9. Okay, we know that this part of the side is 120.9. If I combine that with the 44 we've already got, I should be able to get the whole side. So in theory, we should be able to combine that with, it should be 100 and, I'm going to say 164.9, but unfortunately I'm doing the audio after I've already recorded it, so pretend it says 164.9, because that's the way, because that's actually what I put in the calculator, it's just not what I wrote down. Okay, and if you times all of this out, you get this weird answer of 8,978.8, and if we really want it to be perfect, we're going to put units squared on it, just because why not? And there's your answer. And that's how you use trig to get the final result.